What's up, everybody? Welcome back. Today we are working on our user space USB driver for an Xbox controller with the intent of having a test bed in place for when we eventually make our own Xbox controller. That's kind of the long-term goal here. And so the thought here is we have some built-in Linux drivers, right? But once we start trying to implement our own Xbox controller, we're going to have some USB interface, that sends stuff to the computer. And what is stuff? We don't really know yet, right? And so we're trying to figure that out, as well as get like a test setup in place so that when we start sending stuff and it doesn't work right, we can like poke and prod it a little bit more closely. And so Linux has support for user space USB drivers. They create files when you plug in a USB device and dev bus USB. So here, these are like device handles that you can just read and write. And when you read them, they can like provide you a little bit of information about that device. So if we look at like dev bus USB 001, 007, in here is like some binary data that represents the descriptor of a USB device, right? He says things like basically the stuff that you see when you type LSUSB, where you see like Ganzu Chicken Run Network Technology Company Limited GameSir K1 controller for Xbox. This is our test device. So yeah, we have written as of last stream a little test app that doesn't really do much. He just kind of opens up that file and he looks at he tries to like query some data about him, right? So he says, hey, what is your configuration? He goes, hey, I have, an interface. And we're like, oh, interface, that sounds exciting. What's that interface? He's like, oh, I'm a thing. And this is kind of like my idea if you want to do something with that. And here is like the number of endpoints I have. And if we look at the endpoints, that's the interesting part, we think, is this is how you actually talk to the guy. So here he says he has two endpoints. One of them says they're both endpoint 2. It says 130 and 2 here, but it turns out that 130 is just the same as 2 with the 7th bit set. So if you go like you go 0B1 10, that's 2, right? And then you throw 0 1 2 3 4 5 6, throw a 7th bit on there, that's 130. And so that's their way of saying like, hey, we have an endpoint. It has, you can send inputs to it, you can send outputs to it. And here he says, I have attributes which kind of define how you're supposed to talk to me. So the USB protocol allows us to do bulk transfers, interrupt transfers, control transfers, and isochronous transfers, I think are the names of all 4 of them. Bulk is basically like, I'm sending you lots of data. Isochronous is like, I'm sending you lots of data at a fixed interval. Interrupt is like, sometimes I'll send you not that much data, but you should check. And control is like, configure me please, right? And so it turns out that if we look at the attributes that this guy has, if we check the USB spec here for the description of what the endpoint attributes are, one of these things is attributes, and he says I'm an interrupt endpoint. So we have one interrupt endpoint that goes in and one interrupt endpoint that goes out. And the goal for today is to try to talk to these guys and get some data, right? We don't really know what that data should be, right? We were looking at this thing called the Xbox Gaming Input Protocol. And it just turns out we thought that was going to be like the definition of the specification of how we're supposed to talk to our controller. But when we looked at it, it was not. It did not match up with our device. So I think what we're going to be doing is we're going to be referencing the Linux kernel XPad driver. If I look up GameSir in here, there is there's a device from the same vendor that's supported in here. I think it's basically the same thing. I don't really know how he resolves this stuff, and this might also be like an out-of-date clone of Linux kernel. I haven't really looked, but here he says like, hey, I'm an Xbox 360 controller, not an Xbox One controller, Xbox 360, and we kind of use this driver as like a reference for how you're supposed to use this thing. So we were just looking in the pre-stream segment about like what they do, and they basically say, let's allocate a USB request block, a thing that basically represents a USB transfer in the context of Linux kernel, and he does a bunch of stuff. He does some stuff, but really I think the stuff that matters is he initializes this request block with some stuff that he's queried from the driver or from the controller. And then he calls, I think I saw it as like init start input, I think is what we saw eventually. He calls this start input function, and that submits the request block to the Linux kernel. The Linux kernel will like post that whatever aspects of that thing are relevant to the USB controller. It will wiggle the wires. The controller will answer, and eventually he will respond with this function here. So when we set up this request block, we say, hey, Linux kernel, when you get a response to this thing, could you please call xpad irq in? In here, he says, given the type of Xbox 360 packet, let me process this packet, right? I think this is kind of like the flow that we should expect to see. I'm not really sure, but that's kind of what my expectation at this point. So our goal is to do a similar thing from user space, and it turns out that they have some API that lets us send something very similar to the kernel space USB request block. But I think they said that on completion, it will just like fire some signal number. And so I think that it is time to poke and prod, basically try to connect to this endpoint, try to wiggle the joysticks or something, and see if we get some input back. Because that'd be kind of cool. Be kind of cool, and then we can kind of like work our way forwards, try to figure out like what that thing is. But for now, I think getting anything out of the controller would be hype. So this guy says like basically there is this type USB devfs urb, and you submit this thing with this ioctl USB devfs submit urb. Simple. And so we just have to populate this thing with stuff that makes sense, I guess, and then ship it off to the kernel and see if he gets angry at us. It would be kind of cool if he doesn't, but I don't really know. So okay, let's kind of skim this a little bit more and see if there's anything that if he's going to give us clues about how we're supposed to initialize this thing. So I'm just saying this is for async IO because these are interrupt requests, not bulk transfers. You don't just want to like block on the kernel and wait for it to happen. You're just like, go do this thing and tell me when you're done type shit. These are not, they don't use like poll and select and epoll and stuff like normal async POSIX. They just use their own fancy shit using these endpoints. And we should be using the endpoint number masked with USB dirt in as appropriate. So basically just copy paste the endpoint situation. Buffer length and user context. So buffer, I assume, is the data that comes back or the data that we are sending, right? So probably we are allocating a user space buffer for the data that comes back from our request to end up in. Context is like your typical C, type erased API where you're like, I need to call this function when it finishes, but I'm gonna do something. I'm gonna have some like my own type associated with that thing. So a little void star type shit. Each request can specify a real-time signal number to request a signal be sent when the request completes. I guess can does not imply has to. So maybe we can like poll this pointer to see if the kernel has changed it at all, maybe. When USBFS returns these URBs, the status value is updated. The buffer may have been modified. The actual length is updated here to say how many bytes were transferred if this is set. If fewer bytes were read than were requested, then you get an error report. So I guess that means that we have to know how many bytes we want. Okay. Which I guess means, I think we saw in the XPad driver, they just say 64. Let's see. So here they say XPad packet length here. So what's happening here? They're like, oh, this is output. I think we want input. Here we go. So, okay, same shit though. So they have XPad packet length, which they hard code to 64, I think. Okay, so they're like, give us 64 bytes of data in xpad I data. Okay. They say, let's do this with some interval, which I assume that they get from the device. And here they're probably using like the context pointer of xpad. Probably like they're saying use our driver for our context pointer. So I wonder if we have like user space functions to initialize URBs with the correct shit, or if we're allowed to just like mem set them 0. That would be kind of interesting. It seems like we should mirror this in some way. So I wonder if like, what was this struct called? USB dev fs us urb. Yeah, and then is there anything that we can use to initialize this thing? No, it seems kind of like the only use of this is in the ioctl itself. That's kind of interesting. But I guess fuck it. Okay. And then there's this to talk to the driver, but I don't think we need that. Or ISO. Oh, this is isochronous. Oh, I see, because this might go here. So I assume that we don't need this because we're not an isochronous packet. I assume it should just be like we populate buffer and shit, I guess. Fuck it. Fuck it, fuck it, fuck it. Let's just try something. So, okay. Once we have kind of walked our input table, I guess at this point we're going to look for like output endpoint. And I guess maybe this is a endpoint descriptor. And then if we like, once we get one of these guys, we're like, if you're an endpoint descriptor, we say like if endpoint address. Which one is it? Do we want the one that's input or output? Whose perspective is this from? So in endpoint, out endpoint. So which one is in? In. Yeah, this seems unclear to me. In endpoint. I suspect that this is from the perspective of the host. That's what my gut says. But the polling rate of this is faster. Yeah. Yeah, so let's assume in means in from the perspective of the host. So if this is an input, we say input endpoint, and that matches the naming scheme in xpad driver as well, I think. So I think we're kind of chilling there. And I guess we should kind of we should be a little better here. We should say that this is null. And then here, we should assert that that thing gets set. So assert that input endpoint is not equal to null. In fact, I guess we can just say like, it's fine. Yeah, it's fine. Okay. So now what? I guess we run it. Okay. So we're chilling. we have an input endpoint, and we should be able to just be like, hit me with the endpoint address. So we're gonna create a USB request block. Right, it was this guy. Okay. And I guess in here we start like throwing some shit at him. So I don't know what type is here. Probably like this probably is like interrupt. Probably. How does XPad do this? So what does like this function do? So type here is just not set. Is the kernel version of this thing like different? Struct URB. Yeah, it seems like. Jesus Christ, that's a lot of fields, but I don't see type in here, which is kind of interesting. Okay. I guess we should just look up like USB dev fs urb. Right? This is gonna clear things up. Oh, this is just the same doc we were looking at. But like, surely the definition of this guy might say no. But maybe the ioctl who takes this guy might. Right? Maybe. So this goes into submit URB. Which goes here. This guy turns this thing into a user URB or whatever, who calls this guy, who goes into this. Here we go. Nice. So this is the type field, what they're expecting. They're expecting one of these USB devfs URB types. So I guess here, let's make sure that like our attributes are, you know, what we expect. And so we're just like, this means interrupt endpoint, which means that now we can call USB devfs USB type interrupt. We're like, we want this to be an interrupt packet. All right, field 1. Success. USB devfs URB. What is this thing called? Something like this? Here we go. Okay, type, chill. Endpoint. Endpoint should be chill as well. This should just be endpoint address, I think. Cool. What's next? We got status. Surely status is just 0. Surely. But what about flags? So it looks like they do validate this in some way. So they say, if the flags and any of these, anything that aren't these bits are set, then we are angry. So these are the things that we're allowed to set, I guess. Right, so we're allowed any of these. So I guess that's fine. we can just leave it at 0, I think. That seems true to me. Because this check for eval is checking if any of the bits are set to 1. That shouldn't be, but if we just set everything to 0, he'll pass. So fuck it. Fuck it. Okay. So then we got our buffer. But the but would be the endpoint. I'm sure that was related to something I said, I just don't know what. So we'll say we have a 64-byte packet, because that's what we saw in the XPath driver. And then I guess we put the receive buff pointer here. And presumably we also put the buffer length here, which is going to be an int cast of receive buff len. Boom. Actual length, we haven't received anything yet, so this is 0. Start frame. What are your feelings on using Codecademy to learn? Have you looked into it at all? No idea. No idea. My learning mechanism is always just like poke and prod, try stuff, so I don't have any strong feelings on that. You know, do what works for you. What the fuck is start frame here? Is this even in the same spot, or did I just like end up? Yeah, I think I just ended up somewhere else. Oh no, this is down here. Okay, so start frame is, are we in some like switch case? No. I don't know what this means. Yeah, unsure. Error count probably 0. We'll just put start frame 0 here for now, and then we'll come back to this as like a, you know, I don't know. And then this stuff it explicitly says isn't used because we're not an isochronous transfer and we're not a bulk transfer, so we're neither of these. So we just leave those unset, I guess. Error count, surely 0. Surely. Signal number. Okay, so can we look at sig number? So this just goes into whatever this ass is. The fuck is ass in all of this? Async. The fuck? Struct async. So this is, oh, I see. So this is probably like a user space structure. This is like a structure saying like, unless this is here. Ah, this is just here. So this is in USB device IO. They have an async type. And in here, they're like, we have the USB request block and we also have some metadata about the signaling stuff. So here it's probably like, somewhere they're gonna like call that signal if signal. So async completed. If they have a signal, then they call that shit probably. And I don't see any like validation of the signal number, but I think that we saw in the docs here that the signal should be between some set of numbers. Sig RT min and sig RT max. What are those? Sig RT min. Fuck it. I guess we just set it to sig RT min. Which I guess he doesn't know what to do with yet. But that's okay. We'll get there. We'll get there. Okay, so we must have to submit this guy now. Right? So we call like, I guess, ioctal. So we're like, yo, let's call USB dev fs submit URB with this request. And this probably then we just wait for the response. You know, I don't know. Surely, right? So like we'll sleep for like increments of like 10 milliseconds. I guess we could probably just sleep one time for 10 milliseconds. That's probably enough, but fuck it. Maybe we. And then what do we do? We like. I guess we check that ret is greater than 0 here. Because if it's negative, then this failed. Um. Okay. Where does sig rt min come from in user space? Um. Signal dot h. Sure. Okay, he seems happy with that. And I guess we can just run it and see what happens. Oh, that's annoying. So I guess we need to link libc for this to work, which we have. He just doesn't know what the fuck he's doing. That's cool. Like, what the fuck? Comp time call. Oh, it's comp time because it's a const. Oh, so this is just a fucked up. Oh. So instead we should be calling libc current sigRtmin, I guess. I guess. A little cheaties, but whatever. Okay, so he's mad because our attributes are not what we expected. Why is he mad? So we're not even at the right spot yet. Here it's like what are we asserting on? So what is attributes then? Oh, I meant 0b11, not 0x11. I'm a dumbass. Okay. So it looks like we're chilling. We see real-time signal 0 here, which I guess means that the signal was fired and Zig intercepted that or something with its default signal handler. I guess. Right? If we do this +2, I assume that we're going to see the number 2 here. So that's a really good sign. That means that, like, something happened, right? It means that, like, the request was submitted and got some data back. I think. So I think the next thing we have to do is probably like add a signal handler. Right? So we probably want to like add a signal handler. So how do you do that? It's been a while. Signal is this a ask the idiot angle? Probably. It's probably the fastest way. Uh how do I add a signal handler in Linux? Let's just see if he gives me an answer. That sounds familiar. Is it really that easy? I remember this is more in line with what I remember. Sig action. What's the difference between these two? Man to signal. I'm Steve O. Thanks for the tier 1. 14 months. That's crazy. Is Duck AI DuckDuckGo's AI? It's just like wrappers for the other guys. I just don't like logging into their websites. Okay, so here they say down here something see sig action for details on what happens, blah blah blah. So this guy is just like, give me this handler for this signal. And avoid its use sig action 2 instead. Okay, sure. So we'll just do that. And this is just basically the same shit. We have a signal handler, but we give him some flags. Okay. So what's this guy supposed to do? Do we just have an example down here? We do. Okay, what is like sig info? Signal handler takes 3 arguments, not 1. In this case, we should be using SA sig action instead of handler. Oh, I see. So it's just like a better version. You can like upgrade. So you can use this or this. And sure. Okay, cool. That makes sense. So we'll just copy paste for a second. I guess we can copy paste from down here. Sure. Fuck it. Okay, so before we do all this stuff, before we submit the URB, we want to set up our signal handler. Which is gonna be something like this. And I assume that Zig has like built-ins to make this easier for us. I assume that this is already in the Zig standard library. So we're gonna be like stud OS Linux sig action. This is the function. Sig action here is the structure, which mirrors this guy. Great. What are our options here? So we're like, I want a handler, and we're gonna use sig action here. Okay, that kind of covers one thing here. Then we have mask, which he just didn't set in his example, and flags is equal to SA sig info or something. This is probably not how it's defined in Zigland. Okay, and then we call stud OS Linux sig action on, stud OS Linux sig. How do we get like the runtime signals from here? Yeah, how do they get like the runtime signals in here? Is MIPS, is Spark. Oh, so we're like in this path? I guess it's just like unused is what they want. Sure. So then can we use that here as well? So we don't have to do this? Fuck it. Okay. So then we need our like handler definition. So this is like a pub function sig handler, which gets like some stuff. Okay. And then something like this. You can just say like, got this number. This is probably not valid from a signal handler, but fuck it. Okay. Then we do sig handler here, which actually should be sig handler to follow the conventions of this language. Nice, dude. We are hackers. Hackers, baby. And then here we pass in SA, I guess, and null like this. I assume that this returns the same shit, so this is gonna be. Can we do like stud OS? Yeah, I guess this is a Linux specific. He returns a usize, so we need to like turn this into an I64 probably. iSize. I think that's a better way to do this correctly. Okay, and then return error set signal if we fail. Okay. He doesn't like this because what? I can't read that message when it's that small. Expected this shit, found this shit. So I didn't put an ampersand, it looks like. No, he's like, I expected this, found this. Oh, because he wants I32, not Cient. My bad. My bad. Now he wants I32, I32. He wants not a pointer. Or he wants a pointer to this thing, and he didn't get it. Fine. Expected const pointer, found mutable pointer. Fuck you. Fine, I can read. And then he wants callconf C, so callconf C. All right, boom. This guy's mad because we used the wrong thing here, so it's probably like this. Mask. Oh, that's interesting. Is there like a default sig set, empty sig set here? All right, there we go. There we go. And so we don't get that though. So interestingly, this is just not firing anymore, as far as I can tell. So maybe we're using the wrong signal handler here. What was this? This was UPI, libc. Oh, fuck. Sig, rtmin. Was what it was? Libc current sig rtmin. From the user space API. Because this was doing something before. Am I crazy? Right before we set the signal handler, he was doing something and crashing. Now he's just not, which is kind of surprising. I feel like we haven't really changed anything since then. Interesting. Yeah, before we were just getting the signal and crashing. And I'm pretty sure this is what we did before. Did we accidentally comment out something stupid? No, we still submit the URB. And we are making it to the loop, so we're just not seeing the response now anymore. But the return value is still... The fuck? Am I stupid? Maybe the device is in some weird state now? Yeah, I guess that's a possibility. I could unplug and replug it and see what happens. Not crazy. Except now... the device number has changed, so we gotta fix that. Hold on. Okay. Here we go. Ret is -16. Also, the lights on my controller just turned on. That's new. I haven't seen that before. Okay. What the fuck is going on? That's kind of fun. Maybe I fucked it up in some way. What is -16 here? We've typed this so many times, but here he's supposed to say, like, I get an any type. I have my guys in I size. If signed is greater than -496 and signed is less than 0, then we flip it and enum from it. So that should be chill. Oopsies. Did I do something stupid? So, but like, I don't know what the fuck this is doing because he's like, this is a success, but it's clearly not a success. I don't know, like, how the fuck. There's something wrong with this, I think. I just don't know what. Is E16 is E busy? Yeah, I guess we could just look at the answer here, huh? So it's like 16 busy, yeah. So that's interesting. I wonder if that means that before maybe like the XPad driver is doing some initial setup. Um so can we Oh, this guy's supposedly on. Oh, so that could be it. I might have to unbind echo this sudo t unbind. Okay. So now we are, chilling a little better. Let's see what our return value is now. Return 0. Okay. Yeah, that's super interesting. So it seems like whatever state we were in before is different now. I would like to reattach this the XPad driver and just like make sure that like the gamepad's working. Like, where is the like gamepad viewer? Maybe this is where I've gone before. Yeah. If I like just like click a button on here, I'm not really seeing. Okay, so this guy is definitely on, which is good. Buttons are still doing what I expect too, which is good. So then why? So now we unbind this guy. This guy goes disconnected. Good. And then. Oh! Oh, I just have to press a button. Ah, so there were just inputs buffered before. Press. Aha! Aha, aha, aha. We're geniuses around here. Okay, so that explains a lot. Okay, so here, well, let's go back to std os linux sig unused. Because I think that's the one we put the signal handler for. Bad system call. Is it that, okay, cool. So here I should be able to say when I want to go back to making a signal handler for that guy. Okay. Oh, hi. So he got the thing now. He got the thing, got 33. So that means that in our signal handler now, we should be able to be like, let's just set an atomic variable that's like, look at the fucking URB. You know? So here we should be able to be like, I guess really what we're supposed to do here is probably like set context URB finished is equal to true or something, but I'm just gonna make a global variable. Can we do have like atomic value bool is, something like this? And then say like URB finished, like, I don't know, store true with probably monotonic ordering, right? I think that, or which one of these is like, I don't really care about, uh, I don't really care about like the surrounding memory. I guess I do care about the surrounding memory, huh? It's like, I guess this is like saying, hey, the data in the URB is now good, which means that this is in, I think this is like release. And then here, this is like, I guess that the atomicness probably doesn't matter actually, but I think it's probably fine. So if it's not finished, we sleep. Otherwise, we probably clear out the URB and resubmit. Would be my guess. Would be my guess. Um. Uh. It's probably something like this. So let's just, I guess, here say like URB done. So let's just start here and then work our way forwards. Yeah, okay. So now we probably want to look at what we got, right? So I press A, we see URB done. I press, now if I press it many times, we don't see that anymore. So that means that we probably have to resubmit. So can we do, I guess we probably have to reset status and actual length, but everything else just stays the same. Rec status, actual length, and then we just resubmit, maybe? That sounds reasonable to me. That sounds reasonable to me. All right, let's try that. So now when I run this, we should see like press, 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 press. So every down, up, down, up, down, up, we see a thing. Yo, how much would a Bluetooth gamepad driver differ? No fucking idea. I assume at this level by a lot. I would assume. Because I assume USB and Bluetooth are very different, but what do I know? Maybe they're like surprisingly similar. Okay, can we like look at the content? That's kind of cool. So we have I guess like rec. It's like the buffer, right? We have receive buff. This is where the shit's going. Okay. So we're getting interrupts that this shit finished, but there's no content ever being written, which is kind of interesting. So how would we know? I wonder if we're looking at the wrong endpoint, or we assumed input. Maybe we wanted output. I guess it's like this. Okay, so that's not it. Pretty clearly, like the one that's, you know, changing when we change things is the one that we want, right? A down, A. What? Whoa. Now the buttons don't do anything? What the fuck? Why is it different now? Press, press. Okay, down, up, down, up, down, up. Okay, yeah. Down, up. Okay, so that's again, okay, we're back, What language is this? Zig? But I don't understand why nothing is happening. I guess we might be seeing like errors. Maybe? can we print out our request as well? Because I assume that the like response value is ending up in there, right? So, yeah, seems reasonable, right? We're not seeing errors come back. Yeah, I don't feel like anything in here is particularly problematic. It's just that the buffer is fucking empty. Maybe we don't allocate the buffer. Maybe the buffer is kernel allocated. Maybe they've overwritten it? We have can we look at, or did we not set it? We did. Okay, can we look at the address of the receive buffer? Did we just like fuck this up somehow? So, oh, he didn't like this. We want to like maybe put P for pointer, X for pointer. How do I fucking print this thing as a pointer? As, am I stupid? Const receive buff pointer is a any opaque is equal to receive buff. I just want to see like if it's the same thing on the in from the kernel that's returned. So we have 68, 68 star is pointer. Ah, right, not P. I was in printf mode. Yeah, so it's like it's pretty clear to me that like this buffer has data in it. No? Like what is the point? What is the point? I guess we could look at the IRQ parsing in the XPad driver. Right, so here they have IRQ in, and here they're like, we are an Xbox 360 driver, let's process the packet. And he's saying that he's expecting basically the bits in data from 0 to 2. Data 3, right? The button mask is in data 3. I wonder if it's something like, oopsies. I wonder if like accessing through buffer behaves differently for some reason. I can't get over the signal-based interface. Seems kind of dirty. Yeah, true. Can we read like the docs of like submit URB a little bit more closely again? So there's discard signal, reap URB. I don't know what that means. Maybe we look at the so these guys just taking like void stars, surprisingly. Okay. And then discard URB takes in nothing? Also kind of fucking weird. USB device. What is it called? It's USB dev fs submit URB. Oh my god. USB device dev fs submit URB. Okay, so we saw somewhere in here that it goes into like struct async, and then they had like async complete. Right? And so what do they do in the kernel when this thing finishes? Right? They like, where does this go? Okay, so they put it here. They say when this guy finishes, call this. Transfer buffer length comes from the buffer length. I wonder if it's like short not okay is something that we should be setting. Like, don't fucking give us this back until it's like fucking donezo. Okay. Yeah, there's just something strange here. I would assume that the data gets set by the content in the response. It has to be. It has to be. And the fact that it is noticing something's happening means that like it's coming in at the right time. We're just not setting the right shit. So I guess this ends up as like it ends up like in the USB handling stuff in the kernel, which I think is just going to be a pain in the ass to dig through. Right, he's going to call like USB submit URB, and that's going to go somewhere deep. But we know that he's being submitted with like, you know, I guess I wonder what like start frame is. We could look at like struct URB or whatever the fuck this thing is called. I think it's a struct URB, and we could see if he has like documentation on the flags and stuff. Am I high? Does he not? Oh, it's in async here. Yeah, it's struct URB. Yeah. What is a URB? I've never seen it in the context of USB. I think that it's just like Linux kernel's like name for USB request block, I think it's just like we're doing some USB shit and it's a kernel concept, not necessarily a USB concept, I think. So what is like start frame? Returns the initial frame for isochronous transfers. Okay, so us setting 0 there seemed fine. Then we have transfer buffer. This item is a buffer to or from which the IO request will be performed, unless no transfer DMA map is set. This buffer must be suitable for DMA. Oh, that's interesting. When transfer flag includes no transfer DMA map, the driver is saying that it provided this DMA address which the host controller driver should use in preference to the transfer buffer. So this is interesting to me because it seems like they just kind of hard copy that shit in. Oh, here we go. So what's going on here? Num SGs. So this is a scatter gather scatter list. Okay, where does this come from? Yeah, okay, so we're missing something, but num SGs comes from only for bulk transfers? Yeah, so we're not a bulk transfer, we're an interrupt transfer. So num SGs will be 0, which means we'll be in this case, we'll be in buffer length greater than 0. We should be here. And then we're in one of these two cases. What is like USB M here? Find memory area from the UURB. The fuck? So sure. So they might have found that section. Oh, I see. So they've got like the user space memory mapped probably somewhere, and then they're adding that to where the user space map memory is. They're probably like pinning it. They should be pinning it for DMA, I assume. I'm surprised you can just read and write to an FD for this. Yeah, it's kind of surprising. Would it be maybe more helpful to check libUSB sources? Cheating! But yeah, maybe. Maybe. So is in, if it's not input, then they copy. Here they do a mem set for isochronous transfers. I wonder if that matters for some reason. And then here, what else are they saying here? If there is no transfer buffer, they get mad. So what I'm confused about here, they're like, they malloc the buffer themselves, which is kind of interesting. Right, so I wonder if there's like some bullshit where we're providing it like user space memory and it's not like handling that properly and we're not supposed to do that. Right, what if we set the receive buffer to 0 or to null, I guess, in this case? Does it like allocate that shit internally? No, he gets mad because he goes like, I assume that 22 is E in val, I think, which means like you needed to put some fucking shit in there. I assume. Would have put 0, 0. So then we come back with buffer null, buffer length null. Okay. So if we put null for the buffer here, he goes, nope, not okay, which I guess makes sense. So now I'm back to being confused. He is saying actual length 0 here every time, which is pretty interesting. I wonder if this means we're supposed to do something else. Seems possible. If like after the interrupt triggers, we're supposed to do something, but like the XPad driver, you know, he's just got like, he just reads that shit, I think, right? He says process packet with XPad iData, where XPad iData was fed to the herb at some point. But they did use like special USB allocation. I thought an interrupt transfer doesn't contain data, but it's been a long time. Am I high? I thought it did. Because like otherwise where are they getting the data from? Right? They have a request block. I wonder if we're supposed to be doing something like this. They do that. I wonder if we should be doing that. No. Fuck, where was it? It was in like flags. No, they just don't have that option here. We're only allowed to do these. Fuck. I wonder if we just do like, let's just like, we could just start. We could like just start saying some shit. Hum. I mean, we could double check the spec. You could be right. Isochronous interrupt transfers. So interrupt transfers is not support with those devices. You need to send or receive data infrequently, but with bounded service periods. Requesting a pipe with an interrupt transfer provides requests with following. Blah blah blah. So the maximum allowable interrupt payload size is 64 bytes or less. For full speed, high speed are allowed more. So it does seem like there's allowed to be some data. Did you just make a selection where the cursor was in the middle of the selection rather than either end? I don't know what you mean. in Vim. I think I do like Shift V often. Maybe that's what I did. I don't know. I don't remember. When USBFS returns these URBs, the status value is updated, and the buffer may have been modified. Did we look at the status value? Status 0? Never changing. What is the status field? I assume, yeah, we should probably look at that, huh? Process completion. That sounds kind of hype. What's going on here? Ooh. Wait. So this only happens after we reap the URB. So maybe we're supposed to do that, where user argument is the pointer to what? User URB, which is this. The fuck? So we get the argument in as a void star. Oh, this is an output parameter. Oh, so our request is different than the output, maybe? Ah, so when they call process completion, so when we reap the URB, they literally just get it from the USB device state. Interesting. Which is probably like something specific to the file. Ah, so I wonder if we can only have one outstanding URB at once, or maybe it's like a queue. What does reap mean? I'm not an English native speaker. I don't know in this context. I don't know what this means. I don't even know if it's supposed to be like 2 words. But this makes sense. So the reason that we're not seeing anything is because we're not ever looking at the response. So I guess we want to be like, when this signal fires, we call an ioctl on this guy with reap URB. Surely, right? Okay. And then here, the output of this guy, I guess we can just put him in. I guess putting him back in the request is fine. We just say, like, write that shit back. Okay. So he's unreachable because this assertion failed here, which is not good. With what? Can we print the return value as well? Fuck it, I guess. Invalid. So he doesn't like this. I guess. Why not? It's E inval, right? Is what we're getting? Yeah, 22. Invalid. So do they ever return E inval on process completion? Just fault. So what's that mean? Am I fucking high and stupid and mental? So we are sure this is at 370. Oh, wait. So this is on resubmission. He's getting angry. So maybe that's fine. Let's go like this. Wait. Status changed. Actual length 20. Bytes written. Let's fucking go. Okay. That's promising. Now the problem now is that the thing we resubmit he's not happy with. So probably it's that we're not setting this stuff right anymore. But why? Probably. So we clear out the shit. Can we print out what our request is now? Maybe we should just resubmit the same request and never change it, right? That seems pretty likely. And then can we maybe print the request, you know, the first request we make, just to make sure, so we compare. So the first request we make is here somewhere. This. Ah. So it looks like the stuff that comes back changes these guys for some reason. So maybe those are like, I wonder if these guys turn into like, I don't know, something else. I don't know. I don't have like a good answer. We could look, maybe, if we look at what happens when he does this reap URB. Somewhere he sets the type on this guy. Right, he says user URB. So he sets status, actual length, error count. Oh, no. Oh, we're probably overwriting the first. This is probably supposed to give us a pointer to the user URB that we stored before. We're probably overwriting ourselves with ourselves. I think what happened, I think we're like user URB. This like is like on the stack, right? This is like right here. We submit this, and this pointer gets like stashed somewhere. He gets stored in like the async request here. Then we like reap, and we give him like some pointer to write, and he is actually responding. We thought that he's like copy pasting this and putting it in here, and so we're like, oh, we'll just use the old location. But I think he's actually writing into this value the pointer to this guy again. So we're overwriting probably the first 8 bytes of our structure with just like random fucking garbage. That's my suspicion here. So if we say like output is a pointer to a user URB, and then we say write this here. Then does that do what I expect? No, he doesn't like that. So I'm wrong. I'm wrong. What happens if we write output like this as like the value? He doesn't like that either. Oh, this is on submit though. I'm a dumbass. Ignore me. We want to be doing this on the reap. Okay. So when we get this guy back now, what does he look like? Aha! Yes, okay, I was right. I was right, I think. Nice. Nice. Okay. So at some point we added the signal handler, and then we did at some point we did like uh get any response. And now we're gonna try to interpret that response in some way. Right? I think that's pretty reasonable. We should look up what reap URB means at some point. I feel like we're missing something where very obviously the way we got to this information doesn't feel like the way we were supposed to get to this information. In fact, I don't even know how we stumbled upon this. I was just scrolling the driver and found process completion and was like, where's that called from? Surely that's not the right answer, but you know, it is what it is. Um cool. Cool. So I think that we should be able to be like, let's kind of slim this down a little bit. Okay, so then we reset the request and we go again. Okay. But, lost the flashlight in rabbit hole. It's a funny phrase. I like it. So now we need to process the response. So here we must be looking at like receive buff. I guess we can just look at what they do in the XPath driver now. Right? So we saw it was on like, it's probably something like reap the rewards of the request. Yeah, I guess something like that. Maybe it's just because like word association, the fact that it sounds similar to some other words, but I really feel like reaping the rewards is like a bad way to get rewards, right? I would assume it just sounds like really bad in my mind, but I'm probably just associating it with the wrong word. What the fuck does reap mean? Reap rewards. Oh, you like you reap harvest. Interesting. So it's like you to get all the good things that come with something. Okay, sure. Weird API, but okay. Okay. So they're saying here ABXY should be showing up in data 3, right? So let's see if we get that. So we should be like looking at maybe a hex dump or hex print of receive buff 3. Okay. So here I'm pressing A and I'm getting 10. Then I'm pressing B and I'm getting 20. X and 40. Y I bet will be 80. Nice. What about like bumpers? Bumper I'm getting 2. 1. Left bumper 1. Right bumper 2. Then A triggers. D-pad not triggering. Start and select not triggering. Okay, so bumpers. Oh, right, and I can press all of them at once to get more. Cool. Cool. Shouldn't output be stack allocated instead of a pointer? I think not. Because I think we need to put a pointer to something for it to write the output. I think that this is like, I bet you could write null here and it would be like fine. Or 0. We can try. Oh no, he doesn't like that. Okay. Because it seemed to me from the API that on completion, we lost it. But I think that he was writing just the pointer to the request back. I think. So I think everything is stack allocated. I don't think we have any like anything else there, but it's fine. Whatever. Okay. So I think in order to like process the response, it should just be like Xbox 360 button map. is like an enum u8, and we know that we have something like this. This matches up with what we were seeing just a second ago, so we can kind of, I guess we need to copy with the correct clipboard. And here we're just like, A is 4, B is 5, X is button 6, Y is 7, and then top, like left bumper is 0, right bumper is 1, and mode is 2. I don't really even know what that is. And then I guess really the typical way, I think this is more like a struct thing. I think this is how they do it in like the kernel drivers for those like mask types. I think, right? If we see like that sig action mask, yeah, they have like a structure where they just put constants that are the bit mask. So then we can go like I guess we can like iterate those fields. You know, everything that we have in Xbox 360 button map. I wonder if this does what I want it to. Then we can say like if field and field and well, the field here is like a type. So I guess we want to look at like field Xbox 360 button map field name. This is the mask of that field. And then if data3 and mask, we write that you know, field.name is pressed. Yeah. That sounds right. I wonder if that works. No. Why not? Why not? We should be seeing like spam of all this shit. No. Because I guess fields, these are not fields, I guess, is the problem. If I want to like iterate all of the constants in here, I guess stood meta fields is something else. Declarations. Can I not look at like their constants? That sucks. Zig iterate over constants in a struct. Is that allowed? Yeah, I want. Can we ask the idiot? Can I iterate struct constants in Zig? Not struct fields. Do you think he's a lying piece of shit? My bet is yes. My bet is yes here, but we'll give him benefit of the doubt. We'll give him benefit of the doubt. He's saying we look at the struct fields. I think he's a lying piece of shit. And as expected, he is. So, do we have other options here? Yeah, I wonder if we just can't fuck AI. Your bit feels wrong. You bit shifted things besides one. Yeah, you're right. Brain just not on. Good eye. Good eye. Thank you. But it does seem like we just can't do it this way. I guess you could probably do it this way if it was an enum. It probably would let you do this. Right, we can probably do it like this. Now I assume that when we look at enum fields, now I assume it behaves a little bit nicer. Um, there we go. So now it's iterating them correctly. And do we see pressed? A is pressed, X is pressed, Y. Nice, dude. Hype. Hype. Boom. Right bumper is pressed. Left bumper is pressed. Boom, boom, boom. That's pretty sick. Pretty sick. I'll take it. I'll take it. Obviously there's more to look at here, right? We would have to look at like stick values as well. Start select are on data 2. The thumbsticks are on data 2. What about like the like stick position? Probably these, right? No, this is map D-pad. Where do they have like out here probably? Sticks are looking at data +6 and data +8. So I think there's like more to look at here, but I think that this is like plenty to start working on a driver, right? We've kind of got like the pieces in place for parsing. And I think we've kind of handled like the interesting part of this, which I wanted to handle, which is USB communication. I think we've kind of got that down to the point where we'll be able to play with it on the device side. So I think we call it there for today. Thanks for watching, guys. We ended a little early, but it is what it is. I think we got what we wanted to get done. Quick stream. So thanks for watching. If you like what you saw, we stream most days around 12:30 Pacific time to 4 Pacific time. It is 3 now, so 2.5 hours ago to an hour from now is when you should expect to see us live if you're watching live. If you want to keep up on projects, there's a YouTube link in the Twitch description where the coding segments typically go up. Sometimes we do like other stuff that we stream. Usually we start the stream with something we call like happy hour, which is kind of like vibey. Today we were looking at basically background info that we needed to do this. So we were reading about like the endpoint stuff and the URB stuff, but trying to get to the point where before we start implementing, we're on the right path. Sometimes we do like unit testing. Sometimes we just do like side projects and stuff. But if you want to see that stuff, you have to catch, the other segment live, or if you support on Patreon, YouTube, or Twitch, you will get access to the other components of the VODs. We do that so that, because, this stream will end when I run out of money, right? And so it gives something for you guys. If you want to support, you want to show that you want the content to continue, it gives you something to get, as well as like an avenue to contribute if you want to do that. So please consider, but obviously no pressure. What will you do when you run out? I'll get a job again, like a normal human. But, we're riding the wave while we can. All right. YouTube, peace out. Twitch, let's find someone to raid.